Hi, I'm Safikhani. Here I'm presenting our work with the title of The Influence of In-VR Questionnaire Design on the User Experience. We did this study in the Institute of Interactive System and Data Science at Graz University of Technology. One of the powerful aspects of VR environments that makes them stand out from other virtual experiences is the high level of immersion. Immersion can be described as an objective characteristics of a virtual environment and could lead to a sense of presence. Although presence is the result of immersion, these two terms are theoretically different. The sense of presence can be defined as a subjective illusion of being there. This feeling is the key feature of believing in the environment. Breaking the sense of presence can cause negative emotion in the user. The moment in which the user loses the illusion of a virtual environment through awareness of the real world or inconsistency of the mental model is described as break in presence. Accordingly, the design of the VR environment should be consistent with the user's mental model, and the persistence of the sense of presence should be maintained. A suitable design is needed from the user interface to the interaction system to design a coherent experience in VR. Several design guidelines follow the traditional non-immersive design approach when designing a VR environment. 2D layout for user interface elements, I mean. Although this approach has been well developed and implemented for desktop applications over the years, the question arises whether this design approach can be in contradiction with the intrinsic properties of VR. This question can be investigated by evaluating the user experience in VR with different design choices. Results of a study indicates that 2D interactions gives a good overview, but speech is faster and 3D is more fun. The evaluation of user experience in virtual environment can be done either with subjective method, for example questionnaires, or with objective methods, for example eye tracking or brain activity measurements. Although the use of objective measurements methods is promising, questionnaires are the most frequently used tool in user experience studies for VR. These questionnaires can be used as pre, real-time, or post-assessment method. This study used the term out-VR questionnaire to refer to the traditional paper or web-based questionnaire that users can interact with outside of a VR environment. The implemented user interface object which provides interaction with the questionnaire inside VR is referred to as the in-VR questionnaire. This paper discussed whether the in-VR questionnaire results could also get influenced by the UR representation. In order to tackle this research question, we developed a toolkit to implement the questionnaire in the VR application that can be used as an interface between traditional web-based questionnaire and the VR environment. Our conclusion from the literature indicated a positive user response to in-VR questionnaires. We presented the Immersive Questionnaire Toolkit as a general approach for implementing in-VR questionnaires. Two factors accompany the design language of this toolkit to ensure the consistent VR experience: visualization and interaction. The visual representation of the toolkit was adapted by the overall concept of the virtual scene. The interactions follow the same rules as the other interactive objects in the environment. We integrated the possibility of directly importing predefined questionnaire from the Lime survey database into the toolkit. This figure demonstrates the structure of the toolkit from importing questionnaire data to the post-processing stage. To evaluate the feasibility and performance of our immersive questionnaire toolkit, we conduct a user study by integrating the toolkit in a VR environment. Accordingly, the critical research goals for this study are finding difference in system usability between different designs, investigating the influence of interaction design on the sense of presence, and finding the difference in task load for different interaction systems. We used the NASA TLX questionnaire to investigate the extent of the task workload, System Usability Scale questionnaire for evaluation of usability, and iGroup Presence Questionnaire to compare the impact of the questionnaire design on the user's sense of presence. In addition to standard questionnaires, we asked users to fill out open questionnaires regarding their experience to freely reflect their opinion about each design. We recorded the time spent completing the task, entering the user ID and playing the game, together with completing the questionnaire separately. In total, we had 16 participants, with age between 21 and 35. Most had a university education. 75% of them often play video games, and 44% of them experience cyber sickness before in VR experiences. We provided users, either locally or remotely, a zip file containing a PDF instruction and the main application. At the start, they filled in the demographic and preliminary questionnaire on the Lime Survey website. Then the main application consists of Onboarding Room and 3 main rooms. Onboarding Room familiarizing users with the required interaction and objects. Onboarding Room essential for users without VR experiences or also in the case that they attend to the study remotely. Consideration of a specific COVID-19 protocol for participant is necessary, and we consider them for the user that attend to the study at university campus. Here you can see the gameplay of Onboarding Room. To reduce the probability of cyber sickness through navigation in VR, we use teleportation as the main locomotion mechanism in addition to physical movement. The first interaction in the instruction of the Onboarding Room is teleportation. Following on from this, the user learned how to manipulate the grabbing system and work with the handles and the laser shooter to select objects. At the end, they learned about laser pointer. This tool later will be used in 2D layout questionnaire. On finishing the Onboarding Room, the user encountered the main game environment, which we designated as the questionnaire rooms. According to their user ID, the order of the room is determined by the application between all 6 permutations. The rooms are identified by the questionnaire layout in their 3D, 2D, and web-based. When accessing this environment, the user should enter a specific user ID, as you can see in the left figure. After confirming the user ID, the user goes on to play a game as an activity. You can see the structure of the game in the right figure. This is done by throwing ball to hit targets. The targets move in the predefined paths with different size and speeds. The game ends when the user hits all dogs or reach the time limits. When the users finish the game, they were taken to the questionnaire stage in the case of in-VR layouts. Here you can see the structure of the 3D layout questionnaire object in the scene. This interactive questionnaire object consists of 3 main parts. First, question text and questionnaire progress monitor. Second, the handle of the answer selection and the range indicator. Third, accept and return handle. The user can select the answer with the blue handle and confirm it with the green ones. The 2D layout questionnaire also follows the same structure as the 3D questionnaire, but with similar pointer interaction as in conventional VR applications. The user can select an answer by aiming at the value on the wall using the laser pointer and pressing the accept button. When each room has been successfully dealt with, a specific environment appears, promoting the user to remove the headset and return to the desktop to enter the next level. In this study, we investigated the impact of 2 design alternatives for in-VR questionnaire and compared them to a traditional web-based questionnaire. A statistical analysis of the results showed no significant difference in the case of System Usability Scale. This may well be an exciting result with different causes, and will need a user study with more participants for a full evaluation. One of the probable reasons for this, however, could be that different design approaches did not cause a significant change in system usability. When considering the respective survey duration, there was a significant difference between the 3D design layout and the web-based version. The 3D design requires more time for participants to complete the questionnaire, but the NASA TLX item showed no significant differences. It can be concluded that despite the higher time required for in-VR questionnaires, 3D VR questionnaire did not burden users with more tasks. In contrast, the 2D layout showed a significant difference from web-based on the mental and frustration item of the NASA TLX. This could be due to several reasons. First, there is more task load for users when they fill in the questionnaire in VR. This may be a correct interpretation, but in this case, users should face the same condition with the 3D layout since the 3D layout takes more time. Second, participants are more frustrated when using an in-VR questionnaire with the 2D layout compared to the web-based version. According to this interpretation, users would not be likely to choose the 2D layout over the web-based version. It was our observation, however, that most users prefer the 2D layout over the others. Third, the implemented questionnaire cannot reflect the correct response of the user in the VR environment. This should be investigated further, either with sensory data or other questionnaires. We found a significant difference between the 2D design layout and the web-based version in case of Realism in iGroup Presence Questionnaire. As we explained, the designed environments were the same in all cases. This means that users should not experience any difference in the Realism case. This arises the question of the applicability of this type of common questionnaire for VR studies. Our journey to design the immersive questionnaire toolkit in VR. The current version of this toolkit provides the ability to integrate and share data between the Lime survey website and the Unity game engine. According to our survey, participants prefer in-VR questionnaires over the out-VR ones. However, we need a study with more participants to reach concrete results. As a future study, we will investigate the following hypotheses. Implementing a more consistent questionnaire design in VR could lead to a higher perceived user experience together with greater accuracy for the survey results. Many thanks for your attention.